All right, to wrap up our discussion on optimization, our last example is going to be which points on the graph of y equals four minus x squared are closest to the point 0, 2. Now, we don't actually have to graph this, but let's just keep some things in mind. If we were to graph it, what would this roughly look like? Well, since the coefficient in front of x squared is negative, and since we have an x squared, it's going to be a parabola that opens down with a maximum or a y-intercept at 4. So if we were to just draw a rough sketch, it would look something like this. Y, x. We know that the point 0, 2 would be roughly, maybe not exactly, but roughly right there. What we want to know is from that point going in the same direction either way, what points are the closest? Now, knowing what we know about a parabola, if we called this x1, y1, then on the other side we would take the opposite of x, so we would call it negative x2, y2. Where the y's end up being the same, the x's are just opposites. Now, thinking back to early algebra classes we took, we can find the distance between 2 points using the distance formula. As a refresher, because we're going to utilize this, the distance formula is the square root of x1 minus x2 squared plus y1 minus y2 squared. And one of the points we're using for this is going to be 0, 2. So let's just write a distance function. We'll call it d of x is equal to the square root. We're not going to call it x1 anymore. We're just going to call it x minus 0, because that's the x-coordinate of 0, 2 squared, plus, we'll just call it y now, minus 2 squared, but we know an expression for y. So let's just go and replace y with 4 minus x squared. So we're going to have the square root of x minus 0, which is just going to be x, squared, plus 4 minus x squared minus 2 squared. Well, we can clean up the 4 minus 2. So we're going to continue rewriting this. We're going to have the square root of x squared plus 4 minus 2 is 2 minus x squared squared. Now, if we actually took 2 minus x squared squared and expanded it out, we're going to end up with, rewriting this again, x squared plus 4 minus 4x squared plus x to the 4th. And we can clean that up a little bit as well. So our distance function is going to be the square root of x to the 4th. I'm writing this one in standard form. We can combine those x squared terms, get minus 3x squared plus 4. Now, something to take note of, it would be sufficient enough to say the part that's in that radical, the radicand, is good enough for finding our smallest critical values. So we're just going to rename that as g of x equaling x to the fourth minus 3x squared plus 4. We don't have to worry about the square root right now, because remember, we're going to end up setting it equal to 0. The square root of 0 is going to be 0. That's fine. Let's now find g prime. So we're going to end up with 4x cubed minus 6x. If we set that equal to 0, I can factor a 2x out of 4x cubed minus 6x. So we're going to have 2x times 2x squared minus 3 equals 0. I've run out of space, so I'm going to go on to another page. I can set each factor equal to 0, 2x equals 0, and 2x squared minus 3 equals 0, and solve them separately for 0. So in one case, we're going to see that x is 0. In the other case, we'll add 3, so 2x squared is equal to 3. We can divide by 2, and then take the square root of both sides. So x is equal to plus or minus the square root of 3 over 2. So our critical numbers are going to be at 0, the negative square root of 2, and positive square root of 2. Square root of 3 over 2. And all that matters now is plugging these x values into our function, our y equals 4 minus x squared. So, if we found, we'll just say y equals 4 minus x squared, we can also call that f of x. If we were finding f of 0, we'd have 4 minus 0 squared. That's 4. And that's fine, so we've got a point at 0, 4, but that would be the same line then. So we're not going to use that. We're going to go and put in those square root of 3 over 2's. So we're going to find f of the positive square root of 3 over 2 and f of the negative square root of 3 over 2. Doing that, we would have 4 minus the square root of 3 over 2 squared. The square and the square root cancel each other out. So 4 minus 3 over 2, we can rewrite that as 8 over 2 minus 3 over 2, which is going to be 5 over 2. So we've got 1 point. That's going to be the square root of 3 over 2 is the x. And our y is going to be 5 over 2. And our second point, we're going to put the negative square root of 3 over 2, but we're going to end up getting the same thing, because if we square the negative square root of 3 over 2, we're going to get the same stuff back. So we can take the negative square root of 3 over 2 and say that the y value is also going to be 5 halves. So the 2 points that are closest to the point 0, 2 along this function are the positive square root of 3 over 2, 5 over 2, and the negative square root of 3 over 2, 5 over 2. And that wraps up our optimization lesson.